This is an example to supplement Lecture 2 of Engineering Economy. And in this example, we're going to explore the price and demand relationships in the same way that the earlier in-class example investigated what's the optimal demand for a certain product that's being sold when we know that we want to maximize our profit. And we're going to calculate what is the maximum profit and what are the break-even points, meaning what are the levels of demand that will at first take us from the red of losing money into the black, which is earning money, and then what's the last number of units that can be sold before we've lowered the price too much and aren't earning enough revenue to cover the costs. So in this example, we have a hypothetical group of college students who are entering into a new business opportunity. They're going to be selling turkey jerky, and at a local grocery store they want to sell the turkey jerky where the production of the turkey jerky, maybe the rent that they pay and the rental of the equipment that they have, their fixed costs are $2,500 per month, and then the variable cost, meaning those materials which can be attributed to an additional 1 unit of an additional box of the product, is $10. We also have that the price charged per box is P equals 50 minus 0.1 times D. That's the price-demand relationship curve. We want to find the optimal monthly sales volume, that is the D star that they should be selling in order to maximize their profit. Number 2, calculate what is the maximum profit that can be earned. The range of profitable demand, and that's the D prime, where we have to go through the quadratic equation and find the minimum and the maximum number of units that can be sold in order to stay profitable. And then finally, we're going to graph the cost, revenue, and profit curves. This example will first be worked by hand using the traditional approach and the formulas, and then secondarily, after the hand calculations, I'll go through and demonstrate how this can also be solved in Excel. Alright, this is the example with turkey jerky, and what we know first of all is that the fixed cost is $2,500 per month, so C sub F is $2,500. It says from the problem statement that the variable cost per box of jerky is $10, and so the C sub V is 10. Also in the problem statement we're given the following relationship between price and demand. It's given that price is 50 minus 0.10 D. And so looking at that, the first thing we know is that if there is a price of $50, that there would be, that's associated with zero demand. And so as they lower the price below $50, that's when they start to see demand. Perhaps more importantly, remember that in the price-demand equation, that this term is what we refer to as A, and then it's the slope of the line over here that we refer to as B. And so we're going to be working with the variables of A equals 50 and B equals 0.10. Alright, the first thing that we want to find is optimal monthly sales volume. And what makes this optimal is the fact that it yields the maximum profit. So this is the number of units to sell if you want maximum profit, and of course who doesn't? So D star is the optimal monthly sales volume. The formula for that is A minus C sub V divided by 2B. Now let me remind you that D hat and D star are different. Remember that D hat was the demand that's associated with maximum revenue, and we don't want to operate at maximum revenue, we want to operate at maximum profit. So this is the formula for optimal demand, which is the maximum profit. So if we substitute the values into that we know, it's 50 minus 10 divided by 2 times 0.10, and that is 200 boxes of their product. So that's how many they should aim to sell if they want to maximize what their profit is going to be. And by the way, if they want to get that number of units, what should they sell their items for? Well, we can just easily substitute that into the price equation. We know that the price will be $50 minus 0.10 times however many boxes are sold. And so that works out to a price of $30 per box, because it's going to be 50 minus 20. And so that's $30 per box is the sales price that will yield 200 boxes of monthly volume. Alright, so what is the maximum profit that they're going to make? Okay, the maximum profit formula is it's going to be the total cost I'm sorry, I made a mistake. It's going to be the total revenue minus the total cost. Alright, and so the revenue is the money they get from sales, and if they're selling 200 units at $30 per box, that's going to be their sales. And then their total costs. The costs that we were identifying at the beginning of this example is a fixed cost of $2,500, so we're going to be subtracting the fixed cost of $2,500, and then also there's the cost of 200 units being made at $10 per box, and so that gives them an additional $2,000 right there in costs, and so that is $6,000 in revenue and $4,500 in costs, which means that their maximum profit is going to be $1,500 on a monthly basis. And I think this is on a monthly basis, yeah, month, per month. Alright, what about the range of profitable demand? Okay, this is the equation we saw in class previously, and if we substitute it's d prime, and remember there are two d prime numbers that we're going to do. Let me switch back to the equation for d prime. Alright, d prime is negative a minus c sub v plus or minus a minus c sub v squared minus 4 times negative b times negative c sub f, and that is all to the 1/2 power and over 2 times negative b. We're going to substitute in all of those values and solve for both of the break-even points. Okay, we have negative 50 minus 10 plus or minus 50 minus 10, which is 40, squared minus 4 times negative b, which is negative 0.10, times the negative fixed cost, negative 2,500, and within the brackets is to the 1/2 power, and all of that is over 2 times negative b, negative 0.10. Alright, so if we go through and do those calculations in the calculator, we have negative 40 plus or minus 1,600 minus 4 times 0.1 negative power, so negative 0.4 times negative 2,500,
1/2 power divided by negative 0.20. This term right here is 1,000. So we've got negative 40 plus or minus the square root of 1,600 minus 1,000, so that's 600 divided by negative 0.20. Okay, so that's going to be negative 40 plus, and the square root of 600 is 24.5 divided by negative 0.20. So that's going to be one of the answers, and it is negative 40 plus 24.5 divided by negative 0.2. So that is 77.5. In other words, they should sell 78 to actually make a profit. And the other one is going to be negative 40 minus 24.5 divided by negative 0.20. And that is negative 40 minus 24.5 divided by negative 0.2. 322.5, and they should round down. If you sell more, you're going to be back into negative territory, so the other break-even point is 322. If we wanted to hand sketch what this curve is going to look like, we can either do it for the boxes that are listed there for 0, 50, 100, and 150. But in general, the shape of the curve is going to look like that there's a fixed cost of $2,500 per month. So we could say that this is $2,500 and that's the fixed cost, and then there's going to be a variable cost going up from there, that it's 78 and 322, that the revenue curve crosses over the cost curve. So this is C sub T, that curve there, where this dashed line is C sub F, and anything in between is the variable costs. So we have a range like this. So you can see this is one of our break-even points, this is another. And so the other thing that we learned in this is that the optimal demand is 200 boxes, and that's where we've got this line is parallel to this line at 200 boxes, and so we could say that this point is what we're calling D star, because that's the optimal sales volume. And if we go over here, the profit that they're going to be making, now the profit curve is that lower curve. It looks a little bit like this, and so that the max profit will be $1,500 per month. This is a continuation of the turkey jerky example, and remember that we have a fixed cost, C sub F, of $2,500. Oops, okay, I just want to have fixed cost there and the number 2,500 in the next cell. We've got variable cost per unit, C sub V, is $10 a box. And A, which is the intercept of the cost, the price demand line, is $50. And B, which is the slope of that line, we were given as 0.1. And I want to change the formatting that. It defaulted as currency. I just want it to be general. Okay, so we're going to have different levels of demand that we're going to do in the same way that we did in the in-class exercise. We'll have 0, 25, 50, and let me drag that down. So I highlight them and they're all at increments of 25. You can see the pattern, and as I drag that corner edge down and I'm still holding the mouse button, I'll go up to 350.
The next column is going to be the price, and this is where I'm going to type in the equation that was given for price. And the price equation that was given was P is equal to 50, so it's this, and I'm going to press the F4 button to anchor it, minus 0.1, so it's this cell, and I'll anchor it by pressing F4, times D. Here's the demand. Alright, so I'll drag it down, and you can see it's applying that formula. So what's the effect of anchoring, by the way? If you look at, this is the original formula that I typed in. The formula below it, oops, let me cancel out of that. So the formula below it is still looking here for A and here for B, but now it's looking at the next row down for the demand because I didn't anchor the A reference, and that's exactly what I intend. I want the price for this row, for row 10, I want the price to reflect the demand at row 10, which was 25, and so that's why I didn't anchor this reference, but the other two I did anchor, is I want it to continue to look up here to the constants. Demand is varying, but A and B are constants through this example. Okay, so that's the purpose of me dragging that formula down, and it stays the way it ought to. Another thing I can do besides drag, remember, is go here to the corner and double click, and it'll fill in all the rest of the way. The next column I'm going to have is revenue, and the revenue we can find by having the amount that's being sold, so equals tells it it's a formula, demand times price, and that's how much revenue is being brought in for each of the different levels of demand. We're going to have a column that's cost, and the cost, remember, is the fixed cost, so equals this fixed cost, and I'm going to anchor it. If I failed to anchor it, when I drag that down, it's going to start looking at the next cells below it. So pressing F4 puts in those dollar signs that anchors it. Okay, so that's the fixed cost plus the variable cost per unit, anchored, times however many units we're selling. So that gives me the total cost for a certain demand level, and I click it, and you can see the costs are going up as I make more because the variable unit cost is being applied to how all the additional units that are produced. The next thing we have to do is solve for the profit, and the profit is going to be the number of, it's just the revenue minus the cost, and so it's the revenue, which is this cell, minus the cost, which is that cell. And it's formatted right now as currency, so I'm going to be changing that. I like it just to be as currency is what I like. It was in accounting where it turns it red. That's a little bit strange, I think, for it to be turned red and with the parentheses to make a negative number. So when it's in terms of money, I actually prefer currency. Drag that down, and you can see that there's a certain point at which the profits go from negative to positive, and that matches up with what we saw in the paper version of this, that it was at 78 units, and so more than 75 you want to sell for the profit, that first break-even point. The example asks us to make a graph based on this information, and so now I'm using Excel 2010, and Excel 2010 has a little bit different functionality than Excel 2013, which is installed in the lab computers, just in terms of where the buttons are. But let me do this, insert, and then I'm picking a scatter chart, and I'd like it to be the smooth one that doesn't show the data points. It automatically sort of, in this case, guessed right. It's got the price curve, which I don't necessarily want to have graphed, but it's kind of a rare thing that Excel will guess right. So what I'm going to do, I'm going to delete all those ones that were automatically put in there. I'm going to select data, and if I wanted to remove just the price curve, then that would be a pretty good graph. But let me show you, starting from scratch, when you insert a chart and it doesn't select the data, you'll have to go over here to select data, and we're going to add 3 series. The first series, I can either type it in or I can just click this box, and it's going to be revenue. And so the X range for the revenue is going to be the demand. That's what we want to be on the horizontal axis. And the Y is going to be the revenue. All right. And you can see it's already starting to fill that in pretty good. So, okay, and I want to also add another series. This one's going to be cost. And we'll have the X range and the Y range for cost. And add profit, the X and Y for profit. Okay, so we're back to where we were when Excel automatically had created it, but at least we got the demonstration of how to set it up if Excel doesn't get things quite right. The final thing I'd like to add here is the axis labels and also changing the range. I'll do the range first. So if I right click on the numbers of the vertical axis, it brings up a menu, one of which is to format the axis. So I want to have it go from 0 to 7,000. 7,000 is the upper range is fine, but I don't really want to show those negative ranges. They don't mean anything to me. All right, so now that's looking a little bit better. I'm zoomed in on the portion of the curve that I'm interested in, but I still would like to have the axis labels. So I'm going to go here to the layout, and the axis labels that I want to add is the horizontal and the vertical. Oh, but I don't want the vertical to be like that. I prefer, let me delete this one. I don't know why I like it, the curved sideways one, but I do. Vertical. I just did it wrong again. All right. Rotated, there we go. Okay, so this is going to be amount in terms of money. And here, this is going to be demand or units sold. And that concludes the illustration for this example.